Hello everyone, this is our session 2 on integration, indefinite integration. We were on exercise 3.1. We finished with question 1 of the same. I had done two parts of that question. I'm moving on to question 2 now. Okay, so in question 2 again, we have some trigonometric terms to find out the integration of. So it just says evaluate, and then they have given integration functions of each. Okay, so I'll do a few of them, 4 of them, let's say, for you, and the remaining you can try on your own. Okay, let me begin with the first one itself, integration of tan square x dx. It's quite simple. So exercise 3.1, question 2. Okay, the first one, integration of tan square dx. Tan square x dx. Now, when we had done the integration formulas in the previous session, we did not have any formula for tan square. If you remember, we had a formula for sec square x dx. So what we are going to do is we are going to convert this into sec square x dx. So how do you do that? We have an identity for tan square, that is 1 plus tan square is sec square. So instead of tan square, I can write sec square x minus 1 dx. Okay, in the bracket I'll just put the identity. So 1 plus tan square x is equal to sec square x. Okay, this is your identity. Now let us integrate this. So how do you integrate? It is a minus sign, so we're going to separate the integration for each one. So integration of sec square x dx minus integration of dx. Right? So this will be, what is integration of sec square x dx? It is tan x. Okay, minus, what is integration of dx? It is x plus c. Integration of dx, I told you, is getting together all the small dx together, and so you get the answer as x. So tan x minus x plus c is your final answer. Okay, this is question 3.1, question 2, sorry, exercise 3.1, question 2, first one. Okay, now I'll do the second one for you. So second one is integration of sine of 2x upon cos x dx. Simple. Just use the sine 2x formula. So what is the sine 2x formula? It is 2 sine x cos x, right? Divided by cos x multiplied by dx. Okay, so cos x cancels out. You are left with 2 outside integral sine x dx, because 2 is a constant, so we don't integrate constants. 2 as it is. What is integration of sine x now? Minus cos x plus c. Okay, remember, derivative is positive, integration is negative. Minus cos x plus c. Derivative of sine x is cos. Okay, and integration of sine is minus cos x. So answer is minus 2 cos x plus c. Okay, this was your second sum. Let's move to the next one. Okay, the third one is a similar function. You have, let's say, integration of sine x upon cos square x, okay, dx. So what we'll do here is we are going to separate this cos square as 1 upon cos x into sine x upon cos x. Okay, now why did we do this? So if you'll observe, what is 1 upon cos x? It is sec x. And what is sine x upon cos x? It is tan x. And we do have a formula for integration of sec x tan x. And what is the answer for that? It is sec of x plus c. Okay, so basically, how do I know that I have to separate or you can say split the denominator? So we need a lot of practice for these kind of sums. They are simple. They're hardly 1 mark or 2 marks at the max for any exam. So we need to do a lot of practice on the same. So it becomes very visible to you that, okay, I can convert it into sec x tan x, and that's the answer. Okay, so it could also be a part of MCQ because it hardly takes 30 seconds to do this kind of a sum. Okay, this is third. Let's move to the fourth one now. The fourth says integration of cos 2x divided by sine square x, okay, dx. So what can we use over here? So first let us use the formula for cos 2x. So I know something about cos 2x as cos square x minus sine square x, okay, upon sine square x dx. What I can do is I can separate the sine square x to each of the terms. So I'm going to get cos square x upon sine square x, okay, minus sine square x upon sine square x. Just giving the denominator to each of the terms in the numerator, okay, dx. So what do we get here? Integral of cos upon sine is cot square x, right? Now put the dx inside and minus integration of sine square x cancels, so dx. Okay, so what is integration of cot square x dx now? We don't have anything for cot square, so what we are going to do is convert this into cosec square. How do we do that? By using the identity 1 plus cot square is cosec square x, right? So we can say integration of cosec square x minus 1 dx, okay, minus dx, okay. So let's separate this also. So you'll have integration of cosec square x dx minus dx minus integration of dx. So what do we get? Integration of cosec square now? It is minus cot x from the formula, okay, minus x plus c, which is minus cot x minus 2x plus c, okay. This is for fourth sum. Let's move to the next one. Fifth sum. So it says integration of cos 2x divided by sine square x cos square x dx. Okay, so this sum is similar to the previous one. Just use the cos 2x formula, split the denominator, and that would give you the answer. This will be cos square x minus sine square x, right, divided by sine square x cos square x. Okay. When you split the denominator to each of them, you'll get integration of, when I put the denominator for the first term, I'll get 1 upon sine square x, that is cosec square x, minus, I'll get 1 upon cos square x, that is sec square x, okay, dx, right? So what will we do? We separate the integration sign to each one of them, cosec square x dx, right, minus integration of sec square x dx. We have formulas for these two. Yes, we do. So cosec square x dx is minus cot x, right, with a minus sign already there. Yes, and integration of sec square is tan x plus c. Okay, so that is your final answer for question number 5. And question 6 now. Question 6 says integration of sin x upon 1 plus sin x dx. Right? So now how do we solve this sum? So you can use your normal rationalizing method, that is multiply and divide by 1 minus sin x. When I do that, in the numerator I will have sin x, 1 minus sin x, and in the denominator I will have 1 minus sin square x, right? What is 1 minus sin square x? It is cos square x, right? So we are going to get integration of sin x minus sin square x divided by cos square x dx. What will we do now? We'll separate the cos square x to each of the terms in the numerator. That is giving the denominator to each of the terms in the numerator. So I'll get integration of sin x upon cos square x minus integration of sin square x upon cos square x. dx. Do not forget to write this with respect to x it is. Okay, so we are going to get, this is like the first or second sum that we just did. So we just separate the cos x. So 1 upon cos will become sec x and sin upon cos will be tan x dx minus integration of what is sin upon cos? This tan square x dx. Okay. What is integration of sec x tan x? We already know it is sec x. Okay. Minus, how do you integrate tan square now? So you do not have any formula for that. So you're going to write it as sec square x minus 1 dx, okay, which is sec of x minus integration of sec square of x dx minus into minus plus integration dx. What is integration of sec square x dx? It is tan x. So sec of x minus tan of x plus x. And the last thing, plus constant c. That is the answer. Okay. 6 sums. I have done around 6 sums of the question. You can try the 7th and 8th of the same part. Okay. I'll move on to the next question now. Okay. There are around 10 questions in this. So I'll do the 9th and the 10th one for you, leaving 2 sums for you. This was 6th one, 7 and 8 I leave up to you. I'm doing the 9th one now. Okay. So the 9th question is integration of 1 minus cos 2x. Okay. Root of 1 minus cos 2x. Okay. So let us do this. So what will we get? We'll use the same formula for cos 2x. It is integration of sin square x plus cos square x. Okay. Minus, what is cos 2x? We have cos square x minus sin square x, right? So when you open the brackets, what cancels out? So we'll have integration of under root of sin square minus cos square plus sin square. So we'll have sin square x minus cos square and plus cos square cancels out, and you'll have plus sin square. So we can write this as 2 sin square x dx, okay, which would be integration of root 2, okay, sin x dx. You know, root 2 is a constant, so it will come out. So we say root 2 integration of sin x dx, simple. What is integration of sin x? It is minus cos x. So root 2 minus cos x plus c. You can write it as minus root 2 cos x plus c. This is your final answer. Clear? Okay, I'll do the 10th one now. It says integration of 2 sin 4x cos 3x dx. Sorry, it is sin 4x cos 3x dx. Okay. Now, what formula can we use for this? So this is something like sin A cos B. Let's say if I multiply and divide by 2. So I'm going to get half outside integration of 2 sin 4x cos 3x dx. So what can we say about 2 sin A cos B? So basically it is the addition of sin A plus B plus sin A minus B. So I'll just put the formula over here, what I'm going to use. So 2 sin A cos B, okay, is equal to sin of A plus B plus sin of A minus B. Okay, this formula I'm going to use over here. So 2 sin A cos B. Do I have something like that? Yes, I have 2 sin 4x cos 3x. What can I use then? Sin A plus B plus sin A minus B. So what I have done here is I have first multiplied by half or rather say 2 on both, multiply and divided by 2. So I'm going to get half outside, integration sign. In the bracket, we'll put 2 sin a cos b can be written as sine of a plus b, that is 4x plus 3x, so 7x, plus sine of a minus b, that is 4x minus 3x, that is sine of x dx. Okay, simple. So what we do, we put half here, we take bracket and we say integration of sine 7x dx, right, plus integration of sine x dx, plus, okay, yes. So now how do we take the integration here? So it will be half outside. The final answer, sine 7x integration minus cos 7x divided by 7, right? So we divide by the coefficient over here, so minus cos 7x divided by 7, okay? Then we have plus, what is sine derivative? It is minus cos x upon 2, okay? What is this upon 2? This is the half that I'm putting inside the bracket now. So it will be minus cos 7x upon 14 minus cos x upon 2 plus c. Always try and get the final answer in the most simplified form that you can. That will be the answer for integration. Clear? So this is your 10th sum, question 2. Now let's move to the third question of evaluation. Okay, so question exercise 3.1, question 3. Okay, it says again evaluate. So let us evaluate the first one now. So it's a different type now. It is about, let us say, it's numerator upon denominator type, and we don't have any formula for integration as we had for derivatives. So there's a different method to approach this sum. Okay, so there's something called as numerator upon denominator. Anything when you have in the form of numerator upon denominator, how will you solve? So we say numerator upon denominator is equal to, so whenever you do any division, what do you get? You get quotient plus remainder divided by d. D is the divisor here, okay, or the denominator. So basically, we can say that numerator can be expressed as divisor into quotient plus remainder. Correct? This we have done before. Numerator is equal to divisor into quotient plus remainder, or dividend is equal to divisor into quotient plus remainder. We have done this before and we have learned division. Okay, so this we are going to use for any kind of division sum that we come across. So how can we write x upon x plus 2 in this form? So numerator here is x, okay? X is equal to divisor, that is x plus 2, okay, into quotient plus remainder. Now we don't know this quotient and remainder, and so what we are going to do is we are going to find it out by long division. Okay, so long division, how do we do this? So we have x over here, so we're going to write 1. 1 into x is x plus 2. We'll do subtraction, so this will be minus, this will be minus, plus x minus x cancels and so we're left with minus 2. So x is equal to x plus 2, right, into quotient, that is 1, plus remainder, that is minus 2. That is x plus 2 minus 2. Okay, now why did I show you this long method? You could have used directly, I could tell you add and subtract 2 in the numerator. I could do that. But the reason I'm showing this is right now we have a very simple term for division, right? It's just x plus 2 in the divisor and x in the numerator. You could have longer terms also. And that time you should know the method why I'm adding a particular term or dividing by a particular term. Okay, so we are going to use this as a generalized formula for any kind of division sum. Clear? So it is x upon x plus 2. Now, instead of the numerator x, now I'm going to put this over there. X plus 2 minus 2. Okay, so we can say that integration of x, instead of x, we are going to put x plus 2 minus 2. And denominator, I'm going to write as it is dx. I'm going to separate the denominator, that is x plus 2 upon x plus 2 minus 2 upon x plus 2. okay, dx. This will become 1. So integration of dx minus integration of 2 outside 1 upon x plus 2, okay, dx, right? So now what will be integration of dx then? It will be x minus. Now 2 remains outside. What is integration of 1 upon x? It is log of x, right? So what will be integration of 1 upon x plus 2? It will be log of x plus 2, okay? No coefficient with x, so no division, that is 1 is the coefficient. Sorry, not multiplied, plus c, constant term. That is your final answer. Okay, for any kind of division sum, remember this is the method. That is, you write the numerator in terms of divisor into quotient plus remainder and then solve the sum. Okay, this was the question 3, first one. Let's move to the second one now. Yes, so now we have a little different sum here. Integration of 4x plus 3, or rather not different, but similar type now, but now you have more than x over here. So either you could do express the numerator in terms of factors of the denominator, or you can say 2x plus 1 plus 2, okay, we could do that. So then you can separate the numerator, but then if you are not sure that what I'm writing is correct or wrong, okay, so what do we do then? So what do? We do the division. Okay, so what I'll do is I'll do division over here and use that formula, that is numerator is equal to divisor, or you can say denominator into quotient plus remainder. Okay, so let us do the division. 2x plus 1 is outside and 4x plus 3 is inside. Okay. So we multiplied by 2, we get 4x plus 2. Let's subtract. So we get plus 1. So we have 1 as a remainder, 2 as our answer, and let us express the numerator now. So 4x plus 3 was my numerator, is equal to denominator, that is 2x plus 1, multiplied by quotient, that is 2, right, plus remainder, that is 1. Okay, so numerator now will be written as this. Okay, so let's change the sum now. It will be integration of, what will be the numerator? 2x plus 1 into 2 plus 1 divided by 2x plus 1, okay, dx. And now what's the next step? Separate the denominator to each of the terms. Okay, so I'm just writing that step here, separating denominator to each term in the numerator. Writing it in short over here, in numerator. So we'll get integration of 2 outside, 2x plus 1 upon 2x plus 1, okay, and we have plus 1 upon 2x plus 1. So plus integration of 1 upon 2x plus 1 dx, right? Now this cancels out, so we have 2x over here as our integration, plus 1 upon x derivative is log x, so 1 upon 2x plus 1 derivative will be log of 2x plus 1, and there is a coefficient to x, so divide by 2 plus c. So the answer is 2x plus log of 2x plus 1 upon 2 plus c. Clear? This is how any division sum should be done. Okay, that is the second question of question 3. Let's move to the third one. Integration of sine 4x upon cos 2x. Simple enough. Yes. So sine 4x can be written as integration of 2 sine 2x cos 2x, right? Double angle formula. And we have cos 2x already there in the denominator, so it will get cancelled out. Right? So we are going to get 2 outside integration sine 2x dx what is the derivative of sine? It is 2 minus cos 2x divided by the coefficient, so 1 upon 2 plus c. So this 1 upon 2 cancels out. The answer is minus cos 2x plus c. Clear? So that is your final answer for the third sum. Okay. Now let's move to the seventh sum now, because the remaining are quite same to what we have just done. See, now I've done, okay, I'm sorry, this was the sixth sum, not the third sum. Just a minute, I made a mistake. Yeah, this was the sixth sum, sorry, the question number. Yeah. Now, what I want to tell you is, from question number 1 to question number 4, rather 5, it's the similar kind as to division, that is dividing numerator by denominator. Then I've done the sixth one for you. Okay, moving on to the seventh one, 1 plus sine 5x under root. Okay, so seventh question. Integration of under root of 1 plus sine 5x. Okay. So we are going to use the double angle formula here again, that is, sorry, half angle formula over here, integration of 1 plus 2 sine 5x by 2 cos 5x by 2, okay, dx, right? Now, what we can do is, we can write 1 in terms of the square of these, that is, sine square 5x by 2 plus cos square 5x by 2, okay, plus 2 sine 5x by 2 cos 5x by 2. Okay, this is already there, and this dx term here. Now what can you observe over here? This is a perfect square, and this is multiplication of the first two terms, right? 2 sine a cos a. Basically this is a square plus b square plus 2ab. So we are going to write this in the terms of a square plus b square plus 2ab. So it will be under root of sine 5x by 2 plus cos 5x by 2, okay, the whole square. This is a type of a plus b identity, right? A plus b whole square identity. So this will be, the root sign shifts up. You get sine 5x by 2 plus cos 5x by 2. What we'll do is, we'll separate the integration to each of the terms, right? So we get integration of sine 5x by 2 dx plus integration of cos 5x by 2 dx. Okay, right? So what will be the integration of sine? It is minus cos 5x by 2. Also, we divide by the coefficient. So I'm going to multiply by 2 by 5. Okay, plus cos derivative is sine. So sine 5x by 2 multiply by 2 by 5 plus c. Okay, so what you can do is take 2 by 5 common here. Okay, 2 by 5 outside, and you have sine 5x by 2 minus cos 5x by 2, and your plus sign plus c is already over here. Okay, so that is the answer for the seventh sum. Okay, in the next session we'll do the remaining sums of this exercise, and hopefully we finish with this exercise in the next session. Now, the sums that I have not done, if you have any doubts in the same, you can write to me on the email ID given to you. Okay, thank you so much.